Hi, welcome to this video. This is 9-3. We are talking about the exponent laws and powers of whole numbers. We're going to go ahead and dive right in, and I am going to ask you guys to really quickly identify each of the following values. What is 5 squared and what is 3 cubed? Go ahead, pause video, try that, and I'll reveal the answers here in a second. All right, and so here are the answers. Should be very, very simple. 5 squared, this is 5 times 5, gives us 25, and 3 cubed. 3 times 3, which is 9, times 3, which is 27. Okay, so where we're going with this lesson, and our objective is to write rational numbers as a power of a whole number, and then also write the power of a whole number as a rational number. We really want to be able to break numbers down into exponents and then use them to solve equations. So here's a simple concept. We want to determine the value of x. And so if I asked you 3 raised to a certain value is equal to 9, what's that value? 2, right? 3 squared gives us 9. Now you can conceptually and easily understand this, but this is what we call the exponential property of equality, and where we're going to go with this. So we'll formally define this in the next lesson. So if I have a value or a question like this, and I rewrite the equation with the same base, so know how I go from 3 to the power of x is equal to 9 to 3 to the power of x is equal to 3 squared. Well, if the left is equal to the right and the bases are the same, the exponents have to be the same. So therefore, x must be equal to 2. Okay, and that's again where we're going to go tomorrow. We'll formally define that exponential property of equality. A couple of properties that I also want to introduce or reintroduce to you is the negative exponent property, as well as the property of 0. And here, first of all, a negative exponent means that you have a reciprocal power. And here's an example of how it works. If I have 2 to the power of negative 3, this is the same thing as 1 over 2 to the third. I just move this number from the numerator to the denominator, and then the power changes from negative to a positive. And 2 cubed is 8, right? 2 times 2 times 2. So we get 1/8. Okay. Another example of this would be, what is 5 to the negative second power? Well, I'm going to go ahead, I'm going to move it into the denominator, 5 to the second, and that gives us 1 over 25. It also works the reverse way. If I have a number in the denominator, a base raised to a negative exponent in the denominator, I'm going to take this 1 over 2 to the negative 3. I'm going to move it into the numerator, 2 to the third, and then I'm just going to go ahead and calculate 2 to the third, which is 8. So another example, 1 over 4 to the negative second. Take a second. What is 1 over 4 to the negative second? Okay, so hopefully you went ahead and moved it into the numerator, and now the power is positive instead of negative. So your answer is 16. Okay, so that is the negative exponent property. The other property that I want to add in here, so please squeeze this into your notes if this is not already added to the lesson, is the power of 0 property. So power of 0 property. And the power of 0 property just says any value, I'll say a. Imagine a is a number. What number do you want a to be? Okay, we can work with that. To the power of 0 is equal to 1. Anything to the power of 0 is 1. And you're like, Schwarber, why? Well, here's a little proof. What if I do 2 to the power of 0? Wouldn't you agree 1 minus 1? Isn't that still 0? Okay, now I'm going to use the product sum, or the product property of exponents. Isn't this 2 to the first times 2 to the negative first? Right? If you multiply the same base, you add the exponents, just kind of in reverse. Well, here's that negative exponent property that we were just talking about. If I move this into the denominator, I get 2 to the first divided by 2 to the first. And what's anything divided by itself? 1. Okay, so there's kind of your informal proof for why the product or the power of 0 is a property. Okay? All right. All right, so now here in this first example, actually over the course of the next couple of examples, what we're going to do is we're going to rewrite these whole numbers with powers as a rational number. So we're just going to compute. And I'm going to start out with the power of 0 here. So 2 to the power of 0. Anything to the power of 0 is 1. And then I'll do the positives. These are very straightforward. 2 to the first is 2. 2 to the second, that's 2 times 2. This gives us 4. 2 to the power of 3, 8. 2 to the power of 4. I don't know what 2 to the power of 4 is. Well, didn't you just find out what 2 to the power of 3 is? So what do I do for 2 to the power of 4? Well, you're going to take 2 to the power of 3, right? And you're just going to multiply by 2 again. So this becomes, very good, 16. Okay. And then lastly, 2 to the 5th is 32. 32. So 2 times 2 times 2 times 2 times 2, I think. All right, so those are the positives and the 0. Now I'm going to go back to the negatives. So 2 to the power of negative 1. Well, this is 1 over 2 to the first, which is just 1/2. 1 over 2. 2 to the negative second. Again, I'm going to take the exponent. Or the base and the exponent. I'm going to move it into the denominator. I'm taking the reciprocal. And I'm making that exponent positive now. So 1 over 2 squared, which is 1/4. 2 to the power of negative 3 is 1 over 2 to the power of 3, which is 1/8. And 2 to the negative 4th is 1 over 2 to the 4th, which is 1/16. And I forgot, I had one last one. And then hopefully you noticed a pattern. Did you pick up on the pattern? 2 to the negative 5th. This is 1 over 2 to the 5th, which is 32. Now I do want to highlight some connections here amongst these. Do you guys see how 2 to the 5th, that's the same, I mean, do you guys see the connection here between 2 to the negative 5th? It's 1 over 32. And then if you look at 2 to the 4th and 2 to the negative 4th, 16 and 1 over 16. So there's connections amongst these exponents. It's the same value, it's just the reciprocal of it. Here is the power of 3's. So I'm going to go ahead, I'm going to play the same game. 3 to the power of 0, 1. 3 to the first, well, that's just itself. Anything to the power of 1 is itself. 3 squared is 3 times 3. 3 cubed we already did in the prior knowledge. That's 27. And then 3 to the 4th power, well, that's 3 to the 3rd times 3. So 27 times 3, that's going to give us 81. Say you're not sure, like, man, I don't know what 27 times 3 is, because sometimes we struggle with multiplication. Don't forget, you can write this down, 27 times 3. You can do an algorithm like this, right, where we multiply. And say, I mean, that's a struggle for you. Think about it like this. I want 20 times 3 plus 7 times 3. So what's 20 times 3? And what's 7 times 3? So if we add these together, 60 plus 21, hey, there is 81. Okay? All right, now let's go ahead and look at the negative exponents. So 3 to the negative first is just 1/3. 3 to the negative second, well, that's 1 over 3 squared, which is 9. And then 3 to the negative third, 1 over 27. And 3 to the negative 4th is 1 over 81. Okay, I do have, I believe, one more example. I know, even I'm getting tired of listening to myself talking. Last step, real quick. 4's, here's our 4's. 4 to the 0, 1. 4 to the first, 4. 4 squared, 16. And 4 cubed, 64. 4 to the negative first, 1/4. 4 to the negative second, 1 over 16. And 4 to the negative third is 1 over 64. If you are watching this, I guess I should have said this at the outset. This is supposed to be a non-calculator lesson. So if you're using a calculator, stop it. Stop it. Use the calculator in your head. It's much bigger, hopefully, unless you have a small head. Here you go. Pause the video, try this practice, and see if you get the right answer. All right, here you go. Here is the answers. So please go ahead and check your work. Oh, there's an error here. I did this on purpose for my favorite student who always goes to the bathroom, Bellany Madrigal. She's my favorite. 2 cubed right here. This should be what? Very good. Very good. Yeah. Bellany also said I'm annoying. Is that true? All right, here you go. Here's round 2. Pause the video. Try this one. Okay, here come the answers. Ready or not, here they come. Okay, so hopefully you got those. Not too bad, yeah? Watch out for the common error. The common error that students make is they multiply the exponent and the base. So like if you have 1/6 right here, or here 1/9, that's the most common error. So remember, 1 over 3 times 3 times 3. That's 127. Okay, we're going to go ahead and do 5, 6, 7, 8. Sounds like a song. 5, 6, 7, 8. So we're going to write these as rational numbers. All right, 5 to the power 0, 1. 5 to the first, 5. 5 to the second, 25. 5 to the third, 125. 5 times 5. Okay, now we'll do the negative exponents. So 5 to the negative first, this gives us 1 over 5. 5 to the negative second, that's 1 over 5 squared. So 1/25. And 5 to the negative third is 1 over 125. So some of this is pretty easy, but a lot of the point of this, right, is to just get you familiar with these numbers. So when you see these numbers, you recognize, hey, I can represent that as base 5. And we'll do that in the next example. Here is the number 6. 6 to the power 0. 6 to the power 1. 6 squared. 36, and then 6 cubed. 6 cubed. Again, if you don't know 6 cubed off the top of your head, which I mean, I don't really expect you to, you can go ahead and multiply 36 times 6, right? Or use the quick trick. What's 30 times 6? 180. And then 6 times 6, which is 36. Add those together. You get 216. Bless you. 6 to the negative first. Now we'll just do the reciprocals. 1/6. 6 to the negative second. 1 over 36. And 6 to the negative third is 1 over 216. Seven. 7 to the power 0. 7 to the power 1. 7 squared. And then 7 cubed. 7 cubed. That's 343. 343. 7 to the negative first is 1/7. 7 to the negative second is 1/49. And 7 to the negative third is 1 over 343. Almost there. We have one more example set. 8. 8. Okay, so 8 to the power 0 and 8 to the power first. Those are like almost automatic. 8 squared, hopefully that's automatic for you too. 64. So I can do those reciprocals. 1/8. No. Yes. And 1/64. And then we have 8 to the third. 8 to the third. This gives us 512. Now I'm scared. 64 times 8? Yes, 512. Cool. So 8 to the negative third is 1 over 512. Okay. All right, I have, I believe, a practice problem for you here. So go ahead, please pause the video, compute these values, and then we'll change gears for this lesson. All right, here are the solutions. Did you get these values? You may be wondering why 5 to the negative second is not there. I did that just so you had one less problem to do. Isn't that nice? I know. I'm a kind guy. I tried. Okay, here's the second part of this lesson. We want to go ahead. We want to take whole numbers and then rewrite them as powers. So for this example here, it says write each rational number as a power of 2. So I'll just start all the way to the left. We have 32. That's 2 to the power of 5. 16. 2 to the power of 4. Be careful. The trap there was 16. We see 16, we automatically think, hey, that's 4 squared. Right? That's 2 to the 4th. 8. This is 2 cubed. 4. 2 squared. 2. Well, that's just 2 to the 1st itself. And then 1. 2 to the power of 0. Okay, now we have the reciprocals. 1/2. Well, this is 1 over 2 to the 1st. I'm just going to bring up the 2, and this is 2 to the negative 1st. 1/4. That's 1 over 2 squared, which is 2 to the negative 2nd. 1 over 8. Again, that's 1 over 2 cubed. So that's 2 to the negative 3rd. 16. 1 over 2 to the 4th. And so we get 2 to the negative 4th. Okay, and then we have 1 over 32. This is going to be 2 to the negative 5th. All right, here is the power of 3. We're going to go ahead and rewrite this as power of 3. If you have numbers that you're not sure, maybe start from a lower value. Like here I have 3. Well, this is 3 to the 1st. 9, that's 3 to the 2nd. 27, 3 to the 3rd. 81, 3 to the 4th. 1, obviously that is 3 to the power of 0. And then here we have these 4 options. 1/3, that's 3 to the negative 1st. 1/9, 3 to the negative 2nd. 1 over 27, that's 1 over 3 cubed. So I have to make it negative, 3 to the negative 3rd. And then 1 over 81 is 3 to the negative 4th. Okay, next, power of 4. Oh, here's a practice problem. So go ahead, pause the video, and try these two. All right, here's the solutions to the power of 2. 1 over 16, that's 2 to the negative 4th. 1/2, 2 to the negative 1st. 2, 8, and 32. 32 might have been the trickiest one. 2 to the 5th. 2 to the 5th. Just a connection to maybe some real life experience for you guys. I don't know how much you have noticed memory of like iPhones or other phones, like how it's growing. But you'll notice base 2 is kind of how it grows, right? Like 2, back when I was in high school, long time ago, like, 2007, like iPod had 16 gigs, 2 to the 4th. Well, then they came out with 32 gig, and then the next jump was 64 gig, and then 128. Those are all base 2. They're increasing by 2. Here's another practice problem. Please go ahead, pause the video. Try this one. All right, here are the solutions. Go ahead, check your work. 1/16. Yeah, you see 16? So again, that's the most common error is 16. Be careful. Do you need to write it as a base 2 or do you need to write it as a base 4? And then here is our closure. We want to go ahead and we want to write 81 as power of 3 and a power of 9 and 1/16 as a power of 2 and a power of 4. Go ahead, pause video, and we'll wrap up this lesson. All right, here is the solution for these two. 81, that's 3 to the 4th and 9 squared. And 2 to the negative 4th is 1/16, as well as 4 to the negative 2nd. Hopefully in this video you refreshed your memory on exponents and rewriting whole numbers as exponents. Catch you in the next video. Peace.